we're going to discuss what is Zero Trust architecture. Instead, we're going to focus on security best practices for keeping and saving the secrets in our framework the right way. I'm going to present to you two different solutions, like centralized secrets managers like Azure Key Vault and AWS Secrets Manager. Another tool that I'm going to show you is OWASP Dependency-Check. This OWASP Dependency-Check is part of the OWASP Foundation. We're talking about JSON files because they will be different for each environment. Hi guys, greetings from Bulgaria. I am Anton and this will be our next video part of our course about advanced test automation frameworks development. This time we're going to talk about security best practices. If you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when new videos are published to the 𝐸𝐵𝒕𝒐𝒏 YouTube channel. Also check the awesome 𝐸𝐵𝒕𝒐𝒏 blog because there are many detailed articles that can help you be a much better test automation engineer. In the links below you will find a link to the GitHub repo with the full source code and also some reference articles to deep dive into some of the topics and other video courses. So, before we begin, please clone the repo Polaris White Test Framework. Instead of creating a separate repo for each module, I am creating different branches in this repo. For this particular video, after you clone the repo, check out this security best practices branch. I'm doing so because we're upgrading the framework with each module bit by bit, and you can find all the upgrades in the separate branches. I suggest to watch the whole playlist from the beginning, from module 1. I'm always trying to create these modules separate from each other. However, they're built as something bigger in mind. So I suggest to clone the repo and check the code while together with my explanations in the video, and this will help you significantly. Also, you will find in the description below some jump links if you want to skip some parts. Now, let's discuss the agenda for this particular module. First, we're going to discuss what is Zero Trust architecture. I need to emphasize that for this particular module, I am not going to discuss topics like security testing. Instead, we're going to focus on security best practices for keeping and saving the secrets in our framework the right way, how we can find some vulnerabilities using dependency scans. In the third part, we're going to talk about hiding secrets. Imagine that when we execute our tests in the cloud, as you know, there's many logs like the Selenium logs or the BDD logs that contain what we are typing. And imagine that we can expose this way some of the secrets like the password or the emails. We're not going to talk only about hiding the secrets using environmental variables. Instead, I'm going to present to you two different solutions like centralized secrets managers like Azure Key Vault and AWS Secrets Manager, and we are going to integrate them tightly into our framework and have this backward compatibility with environmental variables. And in the end, we're going to discuss how to hide the secrets in 𝐸𝐵𝒕𝒐 because they have additional capabilities for that, and also we're going to apply the same refactoring for the framework for hiding the secrets in our toast messages and BDD logging. So let's begin. First, what is Zero Trust architecture? Zero Trust is a modern security approach based on the principle of never trust, always verify. Unlike traditional security models that assume that everything inside the network is safe, Zero Trust treats every user, device and service both inside and outside the network as untrusted until proven otherwise. Let's discuss some of the key concepts here. The first one is least privilege access. Only grant users and systems the minimum permission necessary to perform their tasks. This reduces the risk of unauthorized access of data breaches. For your test automation framework, don't grant full access to databases, APIs, or systems. If a test only needs to read data, ensure it has read-only access. For secrets, avoid hard coding credentials in your tests and use secure storages like Azure Key Vault or AWS Secrets Manager to limit access. The next one, continuous verification. Even after initial authentication, continuously verify identities and permissions. This ensures that every access request is legit, especially during long sessions or repeated access. How to apply it? If your tests are running against an API that uses token-based authentication like OAuth, OAuth2, make sure the tokens are short-lived and that tests regularly re-authenticate. This ensures that if permissions change or credentials are compromised, they don't persist throughout long test sessions. For example, in Azure DevOps, when we authenticate our test agents, these tokens are valid only for 30 days or less. This is a rule of thumb for passwords as well. Alright, so the next one is segmentation. Break down resources into smaller, isolated segments, ensuring that access to one part doesn't automatically grant access to everything else. This limits the impact of potential breaches. This is especially true when we work on test environments, because I saw that many teams in the industry, they use the same password or the same user, and this user has access to everything, even if it's test environment, because they think that they're safe and they give this user like this gold vault. So how to apply it? This should be configured with different credentials for each environment. For example, tests running in development shouldn't have access to production systems or data. This helps limit the scope of potential breaches or issues during testing. No implicit trust. No device, user, or network is inherently trusted regardless of its location, whether inside or outside the network perimeter. Every request is treated as potential malicious and is verified accordingly. Alright, so incorporating zero trust into your security model ensures that even if part of the system is compromised, it won't compromise the entire network, offering stronger protection for modern applications and systems and test automation frameworks. Connected to some of the key points part of this architecture, let's discuss dependency vulnerability scans. Nowadays, if you watch some of the previous modules of this course, you know that we are using large amount of third-party dependencies and libraries as NuGet packages. And it's really important to implement NuGet package auditing or dependency vulnerability scans. I'm going to show you now two approaches for doing that. There is one built-in approach into Visual Studio that it's using the NuGet built-in capabilities, NuGet auditing. So NuGet can alert developers to vulnerabilities if they're using the .NET CLI or Visual Studio. This is powered by GitHub Security Advisories database. So when we open here the NuGet Packages Explorer, you will notice that I have this warning sign here under installed. These are our installed packages. I also marked here this checkbox, show only vulnerable NuGet packages. And you can see that I have this top level package, REST because I use it in a couple of my projects to make REST web API calls. From the right side, you can see what the vulnerability scan detected. Here is a short description and we can open this link. There is a suggestion to upgrade it. This is one way of how you can find such vulnerabilities, but you can do this manually from Visual Studio. Another way is if we run the following command, .NET list package vulnerable. This .NET CLI, we use it to run our tests from the command line. And when we integrate into CI/CD pipelines in Azure DevOps, in a second I'm going to show you how we can integrate that in our continuous integration. We use this particular command. After that I'm going to show you one more tool. So after you run this command, on the console you will see these particular results. We have a top level package, it's called REST. This is the version. you can see that this is a moderate severity of the vulnerability, and I always suggest to open these links here that will contain more information about this vulnerability. Let's see what we have there. I opened the vulnerability. This is part of the GitHub engine. Here is the GitHub advisory database that these tools are using. We have a summary, we have a details, we have a proof of concept, how this can be reproduced, and some other references and the impact. Maybe sometimes there are some suggestions about what we need to do. These are the two affected versions. The suggestion is to upgrade to this particular patched version. If you use GitHub Actions for CI/CD, this will be automatically done for you. Another tool that I'm going to show you is OWASP Dependency-Check. This OWASP Dependency-Check is part of the OWASP Foundation, which works to improve the security of software through its community-led open source software projects. In another video, if we discuss security testing, they have quite a lot of projects that help security testing. They have security testing checklists for mobile, web API, web. They also have another tool for that, it's open source proxy for scanning web applications and finding vulnerabilities. This tool helps identify publicly disclosed vulnerabilities in project dependencies. It supports multiple languages, including C#. It's using another database, this database, National Vulnerability Database. You will see that again when you download the CLI version. You can run it without an API key, but it will be very slow. This tool uses this National Vulnerability Database of United States. You can get a key for free. You just need to mention the name of your organization, email address, and the sector. You get the API key and everything will be much faster. I suggest to check the tool documentation. It has many arguments to run it from the command line. It's more powerful than the GitHub version. This is the command here. After you download it, you need to add it to your path environmental variables. And after that, you can call dependency check scan, then path to your project. And after that, you have a format of HTML and an output directory. That's it. After you run this command, the following report will be generated for you. Here is the report. This is the HTML version of the report. As you can see, I mentioned the report directory dependency check report. You will notice that this tool called again the REST dependency, this particular version. However, it caught one more vulnerability in the report portal integration with the Serilock logger. And as you can see, both of them actually have a severity of medium. When you scroll down, you will find a little bit more information about both. If you click on some of the links, you will see that this website will show up with more details about what is the issue and how you can solve it. Now, we can integrate that in our continuous integration. This is Azure DevOps. If you watch the video about results analysis integration, we created this pipeline for running our tests and publish the results. We have an integration with Allure and with Report Portal, but again, here the focus is how we can run these vulnerability checks inside our pipeline. You remember that we have this .NET Core task in Azure pipeline. As you can see from the drop-down, we have different commands like packing a particular project to NuGet package, we can publish it, we can execute all of the tests from the project, we can build it, etc, etc. However, we don't have this specific command for listing all the vulnerabilities, list package. This is why we need to pick a custom command, and our custom command will be list package. as some arguments, we're going to pass this vulnerable so that we can list all the vulnerabilities. By default, this is not going to fail your build. You need additional logic for parsing the results and maybe fail your build. This is why I suggest to download and install an extension for this OWASP Dependency-Check task. It will give you the power to do the same thing that I showed you before with the OWASP Dependency Checker. We need to provide to the projects that we want to scan. As you can see, we can scan more than one project if we use regex expression. You can not only publish an HTML report, but we can generate CSV, JSON, JUnit, and other formats. It's even better, we can upload the reports as artifacts after the build completed. Really awesome. And as you can see, it has many other options. You can provide the NPI key if you got one from their website. You can experiment with some other analyzers. Alright, let's continue with our presentation. Let's now talk about hiding secrets. Let's open our solution. And if I open the Lambda test attribute, you remember that in order to integrate with Lambda, we need this username and access key. So, when developing a test automation framework, security is a critical aspect, especially when managing sensitive information like API keys, credentials, and other configuration secrets. So, integrating environmental variables, Azure Key Vault, AWS Secrets Manager, we're ensuring securely handling of this sensitive data. So, when dealing with this sensitive information, hardcoding them in your source code or storing them in configuration files such as JSON introduces significant security risk, as these files can be easily exposed during code sharing or deployment. Instead, using environmental variables provides a more secure alternative since they keep sensitive data outside of your source control. This is why until now I used environmental variables. However, while environmental variables add an extra layer of security, managing secrets at scale, imagine that you're a team of 20 QAs in your organization. This means that on every development machine, all of the people writing such automated tests need to have maybe 5 to 20 such secrets, depending on the context. This means that if those secrets expire in a month, all of those people need to update all of those secrets on these machines. But imagine you're handling your own build machines. You need to update all those environmental variables again, then you need to update them again in all of the pipelines. Usually in big enterprise projects, we are not talking about one pipeline. Even in smaller projects like 10 engineers, we have maybe 20 pipelines. Imagine the scale of that. It's a lot of maintainability issues, right? This is where tools like Azure Key Vault come into play, offering centralized encrypted storage that simplifies secrets management and access control. Azure Key Vault integrates with other Azure services, enables automated secrets rotation, and provides fine-grained access permissions, making it superior options for securely managing secrets across distributed systems. It's so what is Azure Key Vault? Let me open it here. I created a Key Vault in my demo Azure account. This is the Key Vault. So Azure Key Vault is a cloud-based service that helps safeguard cryptographic keys, secrets, and other sensitive data. It is designed for securely storing and accessing secrets in applications, including automation frameworks. It's centralized management. It has these access policies right here. You can restrict access to specific users or applications, ensuring only authorized entities can retrieve sensitive data. Usually, a completely different team is responsible for configuring and setting the secrets. Probably your admins or Azure DevOps team. They will assign you a role, and on your machine and in your test automation frameworks or pipelines, you will just access those secrets via these integrations. This is usually how it works. So when we create this service in Azure, most of the time you won't have direct access, and this is the whole point of it. We have different people managing it. This is making it harder for someone to steal secrets. When you go here to generate import, you can manually add secrets. You can provide the name here. This will be similar to the name of your environmental variables. This is the name of the secret. You provide the secret itself here. This will be your password, authentication key, etc. We can set even activation and expiration dates for that, and we can enable it or disable it. Another implementation that I'm going to show you, if your company is not using Azure, there are similar tools provided by AWS or Google Clouds. The AWS Cloud tool is called AWS Secrets Manager. I'm going to show you how we can use it as well. In order to start using Azure Key Vault, they offer NuGet packages. One obvious question is how we authenticate. You need to use PowerShell to sign into Azure. If you have access to the Azure Key Vault, the NuGet packages are responsible for authenticating. You don't need to manually store anything on your machine. There are alternative approaches how you can do it. I suggest using PowerShell. After that, you need to install two NuGet packages. This is getting started using the KeyVault secret client library for .NET. So you need to install Azure Security Key Vault Secrets and one more, Azure.identity. This will be responsible for handling the authentication to the Azure cloud. After that, it's pretty simple how we use it. Their SDK, they provide this secret client. This secret client, it requires the vault URL that maybe it is something that you can supply in your JSON configuration, static configuration, or stored in an environmental variable. It will be up to you. After that, we have two methods, getSecret, setSecret. Most of the time in test automation, you just use getSecret. We will get, for example, the 𝐸𝒏𝒕𝒐𝒏 username, the 𝐸𝒏𝒕𝒐𝒏 password, etc. Let's see how we can integrate that into our framework. As you can see here, I implemented one key class called Secrets Resolver. In a second, I'm going to explain what it is, but let's first define the requirement. Since we're building a framework, we cannot force all of our users to use a specific key vault or the AWS Secrets Manager, right? Some of our users might decide that it's easier for them not to pay for that, but to use environmental variables, and that's fine. This is why we can integrate all of them. By creating this utility class, Secrets Resolver, we'll do more than that. This will ease if we need to change the logic later. For example, if you need to switch from Azure Key Vault to AWS Secrets Manager, or to switch completely to environmental variables. You don't need to go into 100 files in your framework to make those changes. Instead of going to the integration project, I'm going to create those classes here in the core project. The reason for that is that all our projects are referencing the core project together with the integrations. Our core classes are located here in the core project. This is why I'm going to move all of those secret managers here. You will notice that I created a new namespace called Secrets, and we have two child namespaces, one for AWS, one for Azure. Here is our Secrets Resolver, combining environmental variables, Azure Key Vault, AWS Secrets Manager, and even using files. If you remember the video about configurations, we have this alternative syntax, not hard coding some of the secrets or usernames. This is the name of the project. If we want to hide something, we can instruct the framework that the value for this key is actually present in an environmental variable. Also, we will have another prefix here called vault and another secret manager to instruct the framework that this value here is present in environmental variable, KeyVault, or Secrets Manager. And the part and the framework will remove the curly brackets, this prefix, and it will replace the whole thing with the value present in this environmental variable. Sometimes we need an alternative syntax, as you will see, because we don't know by default whether this is the real value or it's something holding a secret. And we need additional logic for checking. If this is not a secret, we need to return directly. So we will have a method for that in our secrets resolver as well. Let's first see how the KeyVault integration works. As I said, this is our project, and these are the NuGet packages that I installed. We have one for the AWS Secrets Manager, and I have the two NuGet packages for Azure Key Vault. So both of them have utility classes. These settings are pretty simple. They contain the endpoint, the region, whether this is enabled. For the Key Vault, just the endpoint and whether this is enabled. That's it. So how the Key Vault works. We have usings to Azure Identity for allowing us to authenticate. Then we have a static reference to the secret client. We are keeping the same design, making this class static. Everything here is static and easier for us to use. I exposed one property, whether this is available or not. Depending on that, in our secrets resolver will trigger the branching. We have some initialization logic copied from their documentation. Here we are initializing the client, providing the vault URL, getting from the settings the key vault endpoint. We are just using the Azure Identity NuGet package for initializing it. I mentioned that I initialized that from the CLI. That's it. After that, I exposed the getSecret method. We're calling secret client getSecret by name. That's it. The AWS Secrets Manager works in a similar way. We have a few usings here. The class is static. We have a static reference to the Amazon Secrets Manager. We have a method for initializing the client from the endpoint and the region. One difference is that their method is asynchronous. Instead of making my method asynchronous async2, I simplified a little bit and I called result, which will force to wait here until we receive the secret. Then we need to convert the secret. If it's a binary, we need to convert it to a string. If the secret is a string, then we are going to return it. That's it. And now the secrets resolver. We have one simple method called getSecret by name. This is the name of the environmental variable or our secret in the Key Vault or inside the Secrets Manager. We are getting the environmental variable, replacing this prefix here, environment, as we saw in the JSON config. We are also removing everywhere these curly brackets here. After that, we are checking, do we have such an environmental variable? If yes, then we are not making any other calls to the Key Vault. We are just returning the environmental variable. Else, if the Key Vault is available and we initialize it, then we are calling Key Vault getSecret. Again, we are replacing the vault. Actually, here for the Secrets Manager is another prefix. I have a bug here. It should be like that. Then we are replacing the vault and returning the value. So if we return to our Lambda test attribute, if we use just the simpler version of this method, this is how we are going to use it. Not with environmental variables, but we are going to call our secrets resolver.getSecret, then providing the name of the secret itself, whether this is an environmental variable or the name in the Key Vault. This is version 1. However, as I told you, if we are using the more sophisticated approach using JSON files, you actually don't know whether you need to return directly the value or whether you need to read something from environmental variable or the vault. This is why in our Secrets Manager, Secrets Resolver, we have an alternative method accepting a function called getValue. And this getValue actually will be, as we can see, this is how we use it. Let's remove the comments here. So we have our web settings here. We're not talking, please be aware, we're not talking about static version of the settings for simple projects. We're talking about JSON files because they will be different for each environment. Instead of providing just the name, like here, we use lambda expression, providing web settings, grid settings, arguments, username to string, or any other setting we want to return, for example, not default browser, but something else. The thing that we're going to do here is now our Secrets Resolver, we will need to check if this contains our specific syntax with the curly brackets and environment underscore or vault underscore or sc underscore, then it will do something else. Otherwise, it will just return the actual value present in the configuration itself. So here is the branching. If this begins with curly bracket environment or curly bracket vault or curly bracket sm underscore, we're calling the respective stuff to get the data, environmental variables, KeyVault, AWS Secrets, or we are just returning the value itself. I know that this is making it much harder to use these JSON configurations. This is why I wanted a simpler version of that. The simpler version is if we comment that, we can actually use for the strings. I put this extension method to the Secrets Resolver as well. The only difference is that we have here the key word this config value, and then this is of course static. You can execute this method so that we don't repeat the whole code. Let me uncomment that and proceed with the last part of hiding data lambda test. I executed a few tests on lambda test. If you watch some of my videos regarding single sign-on master authentication, I will put them in the comments below. We have a demo application for login using different formats, like for example using two-factor authentication in these security codes, and also with Google and Meta identity providers with passwordless login using emails and SMS. This is out of the scope of this particular video, but I'm also showing how you can work around CAPTCHAs. And I re-implemented these particular examples, but in C#. But the whole point that I wanted to explain now is that let's rewatch the video. So when we watch the video, the whole thing is that here I'm typing some passwords. We have toast messages. This is the demo app that I'm talking about, and the CAPTCHA. In a second, I'm going to explain really quick. It's out of the scope. This password, as you saw, is the problematic one, because when we type it, if we scroll here, you will see that we have a text command here, right? And usually for the text commands, you're going to see the actual value of the command that is typed. And also you're going to see it right here in the request body. Anyone that has access to your Lambda test account or some of the links will be, the password will be visible to him. As you can see, I protected that by masking it. How we can do that? It's really interesting. There are two problems right now. This Lambda test logs, and the next one is our BDD logging. I'm going to explain how to do both of them. For Lambda test, this is easy. You won't again find this into regular capabilities generator. Actually, when you go to the awesome Lambda test documentation, you will find this section, testing capabilities. At the bottom of this section, the last part is about masking sensitive data. You have a capability called Lambda mask commands. We can hide and redact all of the text sent via the send keys command. This is related to text, emails, passwords, anything else. And also about cookies. If you watch the videos linked below about mastering authentication, I'm explaining how we can speed up the test execution by skipping the login into the application altogether if we have a mechanism for setting the authentication cookies. So often we use cookies, for example, setting shopping carts, setting other important but sometimes sensitive information. This is why it makes sense to hide this into the logs. So at the bottom you will find 4 different languages. In a second I'm going to show you how we can implement that. In my Visual Studio, at the bottom of our Lambda test attribute, we are putting on top of our test classes so that we instruct that we need to run the test inside Lambda test. I have added a new global setting for logging called should mask sensitive info. If this is true, then we are creating this mask commands new string array with set values, set cookies, get cookies. It will be up to you whether to put all of them. I suggest to use the defaults and put the 3 of them. Then I am adding this lambda mask commands, providing the array here. That's it. After that, if you initialize that, everything will be hidden in the logs. However, there is one more thing. You remember that we have BDD logging. When we talked about extending some of the elements, you can see it here. We have it inside the continuous integration logs as well. Also, we can print it into report portal in many places. So you want to hide this information. In the videos on Lambda test, if you turn on the toast messages that I turn off right now so that the test is faster, you will notice that I have actually implemented this asterisk here for hiding some of the secret information. But this is something additionally that I did. I based it again on our should mask sensitive info property. And let's deep dive of how this works. If we go to our components, for example, the text field, you will remember that we implemented that via this event handlers text set. Inside our type text, you will notice that I have one new addition here. This info type is a very simple enumeration, marking whether the information typed inside the input is informational or a secret. And after that, I'm providing the text set. You will notice that we're using the wrapped element, we're clearing the input and sending keys. After that, I'm invoking the event here, text set. I'm providing the component action event arcs. This is the class that holds all the information for the subscribers, all the implementators of this event, all the event handlers. So we have event handlers for the BDD logging and the toast messages and any others. Here, if we look into the actual implementation, for example, for the password, you will notice I have this BDD logging password event handler and I'm calling my logger. I haven't changed anything. I'm just typing this particular action value. This will be my password, or in other implementations, the value inside the text field or the email or the date. I wanted to make it simpler so that I don't need to go over all of those classes. The way this works is that I hide all of this inside this component actions event arcs. I introduced a new variable called action value. When we set it, I haven't changed anything. I'm setting it just to the value that we are assigning, the password and the email. When we return it, you will see that I'm checking the global settings now, the logging settings. Should we mask the sensitive info? Whether the info type is secret, if both of these are true, then I'm returning asterisk, I'm masking it. Otherwise, we're returning the action value. This means that every time we're printing something or validating text, this will be implemented for us. This is how this masking works. We are saying typing this asterisk into the username, whatever, and also this is implemented for the validate. Not everywhere I have set that the text is a secret. For the password components, I'm passing by default when I'm invoking the event here password set, I said that this is always a secret because it's a password. However, when dealing with emails, by default, again, I set a secret, but it will be up to you. If you want to see the emails, then fine, you just change it to info. When you type text, it will be up to you. I implemented this test regarding bypassing the two-factor and the CAPTCHA. When you type the 2FA code, if you don't want the 2FA code to be visible in the BDD logs or in the toast messages, then fine. Now you can say info type and you can say secret. That's fine, and then this will be hidden. But since I added this info type as default parameter, it didn't break all of my existing tests because they continue to work with the original implementation accepting one parameter. The same is valid for validate inner text. If you want to hide it, I have added some default parameters regarding the info type. If you want to hide the secret, you can add it to the validate methods as well. One more thing, to bypass the CAPTCHA, if you watch the video, you will remember that I implemented a way where we have this hidden input. When we set the value attribute to this particular known only for us GUID, then we are bypassing the CAPTCHA. This is really important to be available only for your test environment, not in production. A good practice to hard code this in your code. Instead, I would suggest again to use the secret search and to hide this GUID there. Alright, that's it. So we covered a lot. We talked about zero trust architecture. We saw how we can scan for vulnerability of some of our NuGet packages. This is really important. So always check whether your NuGet packages are up to date. I always suggest at least use environmental variables instead of hard coding data. And if your team is even bigger than 2-3 people, then I always encourage you to use Azure Key Vault because you can later integrate it into your pipelines. I actually forgot to show you that. When you go to this library, it contains some default variables for your pipelines like Key Vault endpoint, Key Vault name, LT access name, username. As you can see, before that I had all of those configured as variable group that I assigned to my pipeline. But now you can use this link secrets from Azure Key Vault as variables. This is really awesome because you can reuse this Key Vault in all of your pipelines instead of going everywhere and linking that and maintaining them in Azure. Again, when you have the Key Vault, it has these access policies. They are much fine-grained. It's really awesome. It's really important to manage these secrets the right way, and always don't forget to hide your secrets inside those logs, BDD logs, those messages, and you have these native capabilities of Lambda test to do so. In the next video, that will be the last module of this course, we are going to talk about execution environments and scalability running your tests in parallel and all of the things that you need to know how to handle that the right way in your framework. Thank you for watching. If you have any questions, put them in the comments below. And don't forget to check the Lambda test blog and the community websites and check the certification program of Lambda test. You can get certified about WebDriver, NUnit, JUnit, and many other technologies. Thank you for watching and see you in the next modules.